So in this discussion, I look at just some sample questions on what we have discussed so far under the atomic structure. So these are some of the sample questions that have come before in some of the ECZ exams. So I want you to see what you can do there. So it says naturally occurring, this was a multiple choice, naturally occurring element Y has 4 isotopes whose relative abundance is shown in the table. So the isotope and the percentage abundance, these are the ones that we are given. So these are in percentages. Then it says find the RAM of the element. So this element Y. So remember, we don't need to go very far when finding the RAM. This was a multiple choice. So what you do, you simply say 1.48, you multiply by 204, close bracket, plus, you go to this one, you say 23.60 multiplied by 206 plus, you go to the next one, which is 22.60 multiplied by 207, close bracket, plus the last one, which is 52.32 times 208. Yeah, you enclose it also in bracket. Whatever you get, you divide, remember, by 100. That is what we did say there. So this was a simple question. You didn't even need to struggle in this exam. So let's work out 1.48 multiplied by 204. In this case, that is going to give you 301.92 plus. You go to the next one, which is 23.60 multiplied by 206. That is giving me a 4,861.6 plus. I go to this one there, which is 22.60 if you want, times 207. So that will give me a 4,678.2 plus. We go to the last one, which is 52.32 multiplied by 208. That is going to give me 10,882.56. Whatever we get, we divide it by 100. So what we do, we just need to add all this. So I already have that, so let me just say plus 4678.2 plus, I come to this one 4861.6 plus 301.92. So this is going to give me, in this case, a 20,724.28. Remember, divided by 100 there. So if you divide this by 100, you are going to find that it is going to give you 207.24. I'll just leave it to 2 decimal places. So this is the RAM of this element that they wanted us to get. So this is how simple you needed to have gone about it. So this was a multiple choice. All right, let's move on and try to look at another question that came in the same question paper. That's the 2021 paper 2, question number 4B. Now this was question number 4B in section B there. So what did they want you to do there? Of course, it says, the table contains isotopic mass units, so AUM, and percentage abundance of element Q that you have been given there. So element Q, there's the one that has got an isotope with 107, the percentage abundance is 52. The one with isotopic mass of 109 has got a percentage abundance of 48. And the question was saying determine the RAM of element Q. So in this case, when we talk about the RAM, that was the A part there. So that's the solution. I'm now looking at the solution. So the RAM, like I told you, get the percentage abundance 52 times 107 in bracket plus. You go to the percentage abundance 48 times 109. Then you just divide everything by 100 there. So what is that going to give us? So it is going to be 52 multiplied by 107. So that will give you 5,564 plus. Please, if you have a calculator, make sure you practice and you key it in yourself. Don't allow someone to key it in for you. Otherwise, you will not be learning. So that we divide by 100. Then we can add the 2, 5564 plus 5232. The answer I get which is 10,796 divided by 100. If you divide by 100, which is going to give you a 107.96. So that's the RAM that you can have. Basically, we can also tell you to use your periodic table to identify the element. So you can round it off. If you round it off, if you basically round it off there, it is going to give you a 108. So on the periodic table, if you are told to identify what type of element it is, you just go to the periodic table and check which one has got the RAM of this one. For example, they told us element Q. It simply means that on top it should be 108. So you look for an element with 108. But if you, of course, if you look for an element with 108, it is actually silver. So silver is the one that has that. So it has got Ag, it has got 108, and the proton number for silver is simply 47. So that's the element. If they told me to identify the element, I just need to use the periodic table and go for the RAM. The number on top there, that is what we call the RAM if you watched my previous videos. Right, let's move on to the B part there. So let's move on to the B part. The B part there says that describe a radioisotope. So what is a radioisotope? Remember what we said? If you followed in my previous video, radioisotope are also called radioactive isotope. We can simply say, you know, this is an isotope. So if we want, I can simply say this is an isotope that is this is an isotope that is unstable. Yeah, an isotope that is unstable and you know, emits a radiation. So it emits a radiation from its nucleus. So that is what we mean. So that is a radioisotope, and that is what you needed to do there. Right, then C says state one use of one carbon-14 isotope. So it's important that you get to know some of the uses of these isotopes. So carbon-14 isotope, what are some of the uses of carbon-14 isotope? Well, let me just give you a few concepts that you need to remember about this one. Of course, you know, carbon-14 isotope is actually a radioactive isotope, and it actually decays slowly. I want to explain some few concepts, please pick them up. So this one actually decays slowly, and it has got a half-life. When we talk about radioactivity, I'll tell you it has about a half-life of 5,730 years. So that is the half-life of carbon-14. That's a long time for it to reduce to half of the origin. It actually takes that long. Now, in terms of uses, basically, you know, carbon-14 can be used in what we call as being radiocarbon dating. So it is actually used in radiocarbon dating. And if you remember, radiocarbon dating indicates, you know, determining. Radiocarbon dating means, you know, it means determining, you know, the age of, you know, fossils. You know, fossils, it could be fossils, it could be bones, it could be wood, or maybe we can simply talk about, you know, archaeological remains. So anything to do with finding it, how long, you know, something has lived, determining the age of something. That is what we are calling as being radiocarbon dating. So in terms of the use that they wanted you to write, you could have said radiocarbon dating. But of course, this has to do with determining the age of fossils. It could be bones, wood, or any archaeological remains. Now, how is that done? Well, normally the way it is that, you know, living organisms constantly take in carbon. So when we eat food, we are constantly taking in this carbon-14, which is radioactive. So when you die, you stop, or when any living organism dies, you know, you stop taking in, you know, carbon-14. So when you stop taking it in, because you have died, it starts to decay or to break down. So now, scientists now can measure how much carbon-14 remains. They can actually measure that, and that will tell scientists how long ago the organism, died. So that is what we call as being radiocarbon dating. Another use of carbon-14 isotope that I can simply tell you, it can actually be used in tracers. It can actually be used tracer in biochemical. It can also be used as a tracer in biochemical research. What do I mean? Well, sometimes carbon-14 compounds can be used to trace chemical reactions that are taking place inside a living organism. For example, if they want to study how plants are actually carrying out their photosynthesis, how the reactions are taking place, those biochemical reactions taking place, or it could be metabolism studies, they can actually use what we are calling as being carbon-14 isotopes. So they are used as tracer in biochemical research. So you could have given any of that. The question was saying just one. Now, when it comes to carbon dating, I know some of you are so much interested in radiocarbon dating. For example, it can be used to estimate the age of ancient anti-craft mummies or trees that have lived. There are certain trees that have lived for longer years. They can use radiocarbon dating. All right, let's move on to and look at C2. Let's look at C2 now, the uses of iodine 131. So what are the uses in this case of iodine 131 isotope? This isotope, iodine 131, what are some of the uses? Well, iodine 131 has got so many, applications today. Now, it has got a half-life. This guy has approximately a half-life of approximately 8 days. So it only takes 8 days if it is within your body, then it will completely, disappear. So some of the uses that I can give you is, one, it can actually be used in, medical. It can be used in medical diagnosis. Yeah, for example, it is used under medical diagnosis. Probably I can say used, to diagnose. Yeah, so it is actually used to diagnose what we call as being thyroid, gland disorder. So you can actually use it to diagnose, thyroid gland disorders, because the thyroid does absorb iodine naturally. In fact, you need, if you go to your biology, you need iodine in order to, form up this, for the proper functioning of the thyroid gland. So now what happens is that a small dose of iodine 131, when given to a person, it actually produces, radiation, and that radiation is actually going to be detected. Yeah, so it can help even to detect, goiter, hyperthyroidism, or even thyroid cancer at an earlier stage. Yeah, so when you have taken that. So one, iodine 131, you could have said medical diagnosis. So you can actually use it in medical diagnosis. B, maybe I can also give you another one. We can also, it can also be used in medical treatment. What do I mean when I say in medical treatment? Well, in medical treatment, for example, what we talked about, it can be used in what we call as being radiotherapy. So radiotherapy is simply used to treat cancer of a reactive thyroid, what we call hyperthyroidism. So it can actually be used in the treatment of that. So medical treatment, of what we are calling as being, thyroid cancer, it is possible. So now in this case, you are going to find that the radiation that is emitted, destroys overreactive or cancerous thyroid tissues over time. Another use where it can be used, it can actually be used, as tracer in medical studies. What do I mean when I say as tracers in medical studies? Well, it can be used in the study of iodine metabolism. So if you want to know the breakdown of iodine in the body, iodine metabolism, or the thyroid functioning, how the thyroid is actually thyroid functioning, how it is actually functioning, they can use this iodine 131. So you can see there are a lot of good uses of these radioactive isotopes. May I conclude by actually maybe trying to share with you some of the common ones that you're going to find, and some of the uses that they can give you, because I don't want just to go, but I can simply give you a few that you can actually get to use. For example, another one, what we call as being cobalt, cobalt 60. If you look at cobalt 60, it is very important. This cobalt 60 can actually be used also in what we are calling as being radiotherapy. So radiotherapy. So radiotherapy, they can also use cobalt 60. Very important. Now this cobalt 60 actually emits what we are calling as being gamma rays, high energy rays. So when these high energy rays are aimed carefully at the site of cancer in the body, they are able to eliminate that one. So it's a good source. Cobalt 60 is actually a good source of gamma rays, so that is what you need to remember. Yeah, sometimes the cobalt 60 can also be used in killing germs. Yeah, so it can actually be used in killing germs and bacteria. Probably in many countries, foods such as vegetables, fruits, spices, meat, they can also be treated with a low dosage of radiation, and that low dosage of radiation can actually include cobalt 60. Sometimes you can also use what they call as being caesium. So caesium 37 can also be used in so these two guys again can also be used to kill germs and bacteria, especially when it comes to the food industries. Medical equipment, they can actually be used to do that. So you need to remember. Otherwise, thank you so much for watching. Watch out for my other videos as I look at some more practice questions. Thank you for watching.